For those of you that don't know, my name is Greg Hoschel, and I run a small instrument company here in Okemos called Instrumented Sensor Technology. The company that I run has been in business for about 20 years, and we design and manufacture a line of computerized sensors, like this one here. Over the past 15 years or so, ATK Thiokol has used our product in monitoring the rail transportation of the rocket motors from Brigham City, Utah to Kennedy Space Flight Center. Any excessive shocks to the motors during transport could result in cracks in the propellant that could be problematic or even catastrophic during liftoff. So quality control, quality assurance is very, very, very important. Representatives from ATK Launch Systems, Mr. Frederick Hendricks in the yellow shirt.
You all heard probably back, I think it was May 2nd in the morning, we had a little incident in lower Alabama where a trestle collapsed underneath the train carrying the segments to Florida. This little black box is attached to every segment that goes from Utah to KSC, and that allows us to verify that that train didn't experience any mishaps along the way, any G's that is outside the design parameters. And so once those trains arrive in Florida, all the data is downloaded out of this little black box, and the engineers look at it, and that's always evaluated before we actually give the go from ATK standpoint for launch. So we depend on this every time. So that's why we're here. We want to thank IST for all of the good things that they do for us and all their quality work, and we just kind of ask them to continue with that. The train, as it looked when it left Utah back in April, we have 2 locomotives at the front. We have a club car, which we actually put our people on to monitor the progress of the train as it goes across the country. And then you can see those 2 white cars, a yellow one and another white one. That is actually the forwards and the aft segments. Each shuttle shipment consists of 8 pieces. We ship a flight set down in 8 pieces, 2 forwards, 4 center segments, and then 2 aft. The white car in between those 2 box cars is the nozzle aft exit cone. And then the last 4 are the centers, and then we have a box car behind, bringing up the rear. We also have what we call a buffer car with some rails attached to it that as the train goes through a trail yard, anything that's coming the other way is going to hit that buffer car first before it hits any of our segments. So we try to protect those segments every way we can as they're going across the country. But anyways, that's what it looked like when it left Utah. You can see our mountains in the background. Next slide. This is what it looked like when it got to southern Alabama. You can see that it was going through a very wooded area. Come across, hit the trestle. This is the lead locomotive laying on its side. Both locomotives went over. The club car right behind it went over. And 6 people were injured when they tipped over. Then you can see the buffer car still on the track. A little closer view. Actually, this was dirt that was brought in by the recovery vehicles so that they could get their tractors and everything to ride the train. But here you can see, here's the buffer car. Here's the forward segment, the other forward segment, an aft, and then the second aft fell over on its side. Okay. Another little view. You can see the business car where our folks were. The last 4, the centers, they didn't really, they stayed on the track. They didn't get that much of a jolt. They think it's because of this box car. When it went down, it kind of helped stop all of the action behind. And actually, they think that when that box car went down, that's kind of what pushed over that segment. And this is the forward segment after they had got the cover off of it and they're examining it. And who knows what that is there?
That's your box.
That's this box right here. Okay, that's where they're pasted onto the segments. This is the forward, actually, because you can see what that big yellow thing is where the igniter goes into for the motor. Okay, next. This is the car that was laying on its side. You can see that actually the wheels stayed on the track, and then the top of the car fell off to the side. Okay, where do you think this box is on that picture? it's laying on the ground underneath all that weight. There's 380 tons, or excuse me, 180 tons sitting on top of this black box. This is the view of that segment that was laying in the dirt. Where do you think this is? Right there. It actually pushed through, the weight of that pushed this recorder through the fiberglass cover. And that's where it was when it came back up. There's a close-up of it. And they kind of moved some of the pieces off and dug it out. And there it is, you can see. It actually pushed, the weight of the segment pushed that through the cover. Anyway, so the data that we downloaded out of that, this is actually the forward segment. That's the one that you saw that came down at an angle behind the buffer car. You can see the X data is the back and forth, or the forward and aft motion. So it took a big jolt. The Y data is the up and down, so it looks like it bounced up. And that's 7.63 Gs, by the way. And then the side to side, so it did a little bit of rocking. Okay, that's the data that we pulled off. This is the aft segment that laid over on its side. You can see that the forward and aft, as those cars ahead of it, you know, it was taking a big beating back and forth like this. Then as it fell down, you got a 7.73 G as it dropped straight down, because this is the vertical. And then while all of that's happening, then all of a sudden that you can see when it fell over on its side, you got the side impact of 4 G, minus 4 G. So anyways, this thing, you know, kept working through all of that. And then after it was over on its side, somewhere along in here, a couple seconds later, we think it's probably because it was laying in a swamp. It gave up the ghost, but yet it still performed enough for us to get all that data to determine, you know, what happened in that event. As far as the forward and aft segments, they were the first 4. You can see that our engineering limits on the back and forth motion are 3 Gs. The forward approach that. The vertical up and down is the significant one here, whereas that aft segment approached 9 Gs when the engineering limits are 2. And then the horizontal, when it flipped over, obviously, you're looking at 3 Gs, 3 Gs. So, next slide. This just kind of shows the centers that were on the back of the train. You can see that not much happened to those 4 cars on the back. You know, they stayed on the tracks. That box car, when it hit, kind of stopped all of the action for those, and they're well within our historical maximums and well within the engineering limits. So our conclusions after downloading the data was that the forward and aft, the forward significantly exceeded their historical maximums, so did the aft. The centers were all within, the aft exit cones were within, and we returned the forwards and afts to Utah. They will not be used. All the propellant will be washed out and the metal hardware will be sent out for testing, and then may or may not come back into the production pipeline. And then the centers continued on to the Kennedy Space Center. So basically, without this little box, we wouldn't have known what happened. Chances are we would have guessed on the conservative side, brought all of that hardware back to Utah and not used any of it, and wasted hundreds of millions of dollars when we wouldn't have needed to.